So let me discuss one very important note, that is difference between XNOR gate and XNOR function. This is very important. Basically, what is the difference between XNOR gate? This is a digital circuit. Okay, XNOR gate and XNOR function. What are the difference between these two? Okay, basically my question is, these two are the same. These two. Okay, this is your XNOR gate and this is your XNOR function. This is XNOR function. This is XNOR gate. Are they same? Are these same? This is my question. Are these same? Okay, ABC XNOR. Then will you get this A XNOR B XNOR C? The answer is no. They are not same. Let me tell you, the answer is no. Okay. So let me explain. Let me explain. Don't worry. I will explain this in a detailed way. Okay. And what I'm trying to say that I will tell you, okay, by the end of this session. And one more thing, that some gate questions in the gate exam, there are multiple questions which are based on this point. Okay. So basically we are discussing a very important point, that is difference between XNOR gate and XNOR function. Okay, basically we are discussing these two, are they same? And the answer is they are not same. They are not same. Okay. So before we discuss this further, let me tell you quick recap of XOR and XNOR function. Okay, let's see the quick recap of XNOR function. Let's see the quick recap. So you can see these functions for two input variables. If you have two input variables, then how these functions will behave? If you have two input variables, for example, if your input variables are A, B, then how these functions will behave? XOR, XNOR. How these functions will behave if you have two input variables? If you have two input variables, there will be four input combinations. These are the four input combinations. Now, what is exclusive OR? This XOR. XOR will be, you can see XOR will be 1 if both the inputs, they are different. Okay. See, A XOR B, that is 1 if A is not equal to B. Okay. So you can see in these two situations, XOR will be 1. And in these two situations, XOR will be 0. What about XNOR? What about this XNOR? A XNOR B. XNOR will be 1 if A, B are same. A XNOR B, that will be 1 if A is equal to B. So in this situation, it will be 1. In this situation, it will be 1. Okay, when both are same, when A equal to B, then this XNOR will be 1. Okay, and when they are different, then this XNOR will be 0. Okay, so you tell me, if you have two input variables, then you tell me, are they complement or not? They are complement or not? You can see XOR, this is XOR, this is XNOR. They are complement of each other. They are complement of each other. Yes or no? You can easily see. If you have two input variables, then they are complement of each other. Very simple point. Okay, so remember this point, very simple point, that A XOR B, that is same as A XNOR B complement, or I can say A XNOR B, that is same as A XOR B complement. Okay, so very simple. When you have two input variables, okay, so this will happen basically for two in Boolean variables, or I can say input variables. Okay, so very simple, they are complement of each other. Very simple point. Now let's see. XNOR is associative, yes or no? This exclusive NOR, that is associative. Remember this XNOR, this is associative. We already know this. Okay, so this is just a quick recap of all the points. So this XNOR is associative. What it means? It means that A XNOR B XNOR C, that is same as see, notice. If I do like this, that will be same as this. Okay, they will be same. Means XNOR is associative. You can easily prove it using the truth table. Okay, using the truth table, you can very easily, you can prove it. Okay, so let me just prove it using the truth table. Let me just prove it. Okay, so let's quickly create the truth table for both these. Okay, let me create the truth table for X XNOR Y. Okay, X XNOR Y, XNOR Z. Okay, similarly, let me create the truth table for X XNOR Y XNOR Z. Okay, so let's create the truth table for these. Basically, we want to prove it. See, I want to prove it. Okay, we can easily prove. We can easily prove using truth table. Using truth table, you can easily prove it. Okay, so just create the truth table. Just create truth table for this LHS. Also create truth table for RHS. Okay, so what will happen? Please tell me. If you have this, for this combination, for this first combination, what will happen? When all are 0, what will be X XNOR Y? Tell me, what will be X XNOR Y? X is 0, Y is 0. What is X XNOR Y? That will be 1. Okay. And what is 1 XNOR 0? What will be 1 XNOR 0? That will be 0. Okay. Similarly, you tell me here, what will be Y XNOR Z? Y XNOR Z, that will be 1. Y XNOR Z, that will be 1. What will be 1 XNOR 0? 1 XNOR 0, that will be 0. Okay, so like this, you can just do it. See, what will be X 0 XNOR 0? X XNOR Y, that will be 1. And what will be 1 XNOR 1? That will be 1. Okay, similarly, you can do here. What will be Y XNOR Z? Y XNOR Z, that will be 0. And what will be 0 XNOR 0? 0 XNOR 0, that will be 1. Okay, so are you getting my point? Okay, you can do this. You can do this for every row. For every row, let me quickly do this. Let me quickly do this. See here. First to do this. First to do the XNOR of these two. What is the XNOR of these two? X XNOR Y. That will be 0. And then you do 0 XNOR 0. That will be 1. Now you tell me, what will be Y XNOR Z? Y XNOR Z. The XNOR of these two. That will be 0. 0 XNOR 0. That will be 1. Okay, similarly, you tell me, what will be X XNOR Y? What will be X XNOR Y? That will be 0. 0 XNOR 1. That will be 0. Okay, similarly, you tell me, what will be Y XNOR Z? Y XNOR Z, that will be 1. 1 XNOR 0, that will be 0. Okay, yes or no? So you can just do it very simple. Okay, very simple. Let me quickly do. Okay, if you do the XNOR of these two, that will be 0. Then you do XNOR with this, that will be 1. Okay, similarly, if you do XNOR of these two, that will be 1. If you do XNOR with this, that will be 1. Okay, similarly, if you do XNOR of these two, that will be 0. And if you do, see, if you do XNOR of these two, that will be 0. And if you do XNOR with this, 0 XNOR with 1, that will be 0. If you do XNOR of these two, that will be 0. If you do XNOR with 0 XNOR 1, that will be also 0. Okay, so like this, you can just simply do it. Simply, what will be this? 1 XNOR 1, that will be 1. Then you XNOR with 0, that will be 0. Okay, next, you can see, if you XNOR these two, that will be 0. 0 XNOR 1, that will be 0. Okay, what about here? 1 XNOR 1, that will be 1. Then you do XNOR with 1, that will be 1. Similarly, here also 1. Okay, can you notice they are same? Can you notice they are same, exactly same? Yes or no? They are exactly same or not? Tell me. They are exactly same or not? Let me know. Yes or no? So they are same. So this is what I'm saying, that XNOR is associative. Okay, this XNOR function, this is associative. So remember, this XNOR function is associative, means A XNOR B XNOR C, that is same as A XNOR B XNOR C. Okay, so this is important point. This is important point, that XNOR is associative. XNOR is associative. This XNOR function, this is associative, means if you have this A XNOR B XNOR C, if you have this expression, and if you have this expression A XNOR B XNOR C, these two expressions, they are same. Okay, these two expressions, remember, these two expressions, they are same. And because they are same, you can directly write, because they are same, so we can write it, because they are same, so we can write it as, you can directly write it as A XNOR B XNOR C. Okay, you can directly write like this, because you know that this is associative. XNOR is associative. Okay, so if you do like this, that will be same as if you do like this. So finally, I can write it as like this. Okay, very simple. Now you also know that XOR is also associative. See, XOR, XNOR, these are associative also, commutative also. Okay, what it means? It means that A XOR B, that is same as B XOR A. This is called commutative property. Similarly, A XNOR B, that is same as B XNOR A. Okay, this is called commutative property. Okay, this is called commutative property. So they are commutative. This is called commutative property. So remember, XOR, XNOR, both are commutative. Similarly, they are associative also. Means if you have XNOR, this we have already seen that XNOR is associative. This we have already seen that XNOR is associative. Okay, also XOR is also associative. Remember, this XOR is also associative. Okay, if you do like this, that will be same as this. Okay, so XOR is also associative. So remember, XOR, XNOR, both are associative and commutative. So this is the point. This is your associative property. This is called associative property. Now let's move on. Now let's see XOR XNOR for three input variables. If you have three input variables, then how they will behave? If you have three input variables, then how they will behave? So let's do it. Okay, let's check it. How they will behave if you have three input variables. Okay, so let's check it using the truth table. From the truth table, let's check how they will behave. Means this XNOR, okay, and this XOR, how they will behave. How they will behave if you have three input variables. For three input variables, how they will behave? Can you check it? Can you check it? For example, if you have this 0, 0, 0, then tell me what this will be. X XNOR Y XNOR Z. It is very simple. If you do the XNOR of these, all these. So for example, if you do XNOR of these two, that will be 1. 1 XNOR 0, that will be 0. Similarly, let's check XOR. If you do XOR of these two, that will be 0. 0 XOR 0, that will be 0. Okay, they are same. What about the next one? What about the next one? XNOR. If you do XNOR of these two, that will be 1. 1 XNOR 1, that will be 1. Similarly, if you do XOR, that will be 0. 0 XOR 1, that will be 1. Yes or no? Okay, what about the next one? If you do XNOR, you will get 0. 0 XNOR 0, that will be 1. If you do XOR, this will be 1 XOR. Okay, and if you do 1 XOR 0, that will be 1. Okay, what about the next? What about the next? You can see if you do XNOR, you will get 0. 0 XNOR 1, that will be 0. Okay, similarly, if you do XOR, that will be 1. 1 XOR 1, that will be 0. Okay, are you getting my point? If you do the next, for example, if you do XNOR, XNOR will be 0. 0 XNOR 0, that will be 1. If you do XOR, XOR will be 1. 1 XOR 0, that will be 1. Yes or no? Okay, what about the next? What about the next? If you do XNOR, this will be 0. 0 XNOR 1, that will be 0. Okay, and what about XOR? If you do XOR, this will be 1. 1 XOR 1, that will be 0. If you do exclusive NOR, then 1 XNOR 1, that will be 1. Okay, and if you do XNOR with 0, that will be 0. If you do XOR, this will be 0. 0 XOR 0, that will be 0. Similarly, if you do XNOR, this will be 1. 1 XNOR 1, that will be 1. Similarly, if you do XOR, this will be 0. 0 XOR 1, that will be 1. So tell me what you can see here. Let me know what you can see here. Can you notice they are same? Can you notice they are same? Please tell me. Can you notice they are same? Yes or no? Can you notice they are same? Please tell me. Please tell me. Can you notice they are same? Yes. Okay, so very simple point. If you have three input variables, then this XOR, this is same as XNOR. This is same as XNOR. If you have three input variables. If you have three input variables, they are same. A XOR B XOR C, that is same as A XNOR B XNOR C. Okay, they are same. So something interesting you can notice. Something interesting. You can see that this XOR comma XNOR. Okay, let's see XOR comma XNOR. If you have two input variables, if you have three input variables, what is the relationship? If you have two variables, if you have two variables, if you have three variables, what is the relationship? Tell me. If you have two variables, if you have three variables, what is the relationship? You can see if you have two variables, they are complement of each other, right? Yes or no? They are complement of each other if you have two variables. If you have two variables, they are complement of each other. If you have three variables, they are same. If you have three variables, they will be same. They will be same. Okay, so this is the point. I hope you got this. Okay, I hope you found this interesting, that if you have three variables, then they will be same, and if you have two variables, they are complement of each other. Okay, and remember, this will happen for odd number of variables and even number of variables. If you have even number of variables, they will be complement of each other. If you have even number of variables, and if you have odd number of variables, they will be same. Okay, if you have even number of variables, they will be complement of each other. They will be complement of each other. And if you have odd number of variables, they will be same. Okay, and see, these simple points we have already seen in our lectures. In our class, we have already seen this. You know that XOR will be one when. Tell me. Okay, if I give you this, tell me, XOR will be one when. This XOR equal to 1. When, if and only if. Tell me. XOR is 1. When XOR will be 1. When XOR will be 1. Tell me. XOR will be 1 if and only if. odd number of ones are there? Yes or no? Odd number of variables are 1. Odd number of variables are 1. Odd number of ones. Yes or no? Odd number of variables are 1. I hope you understood. Okay, very simple point. See, XOR will be 1 if odd number of ones are there. Odd number of variables are 1. Similarly, XNOR is 1. When XNOR will be 1? XNOR will be 1 if and only if even number of zeros are there. Even number of zeros are there. Okay, yes or no? Is this clear? Okay, very simple point. XOR will be 1 if odd number of ones are there, and XNOR will be 1 if even number of zeros are there. Okay, see, for example. Okay, let's see, for example, if I give you this equation, 1 XOR 0, XOR 1, XOR 0, XOR 0, XOR 0. Tell me what this equation will be. Here you can notice you don't have odd number of ones, right? Okay, this is XOR. See, notice here, XOR will be 1 if and only if odd number of ones are there. Odd number of ones. Okay, here you have even number of ones. So remember, this will be 0. This will be 0. Okay, is this clear? Please tell me, is this clear? Similarly, if I do XNOR, if I do the same thing, but if I do the XNOR, then what it will become? Remember, XNOR will be 1 if you have even number of zeros. If you have even number of zeros, yes. So this will be 1. Okay, is this clear? Please tell me. Okay, so remember, simple point. This we have already seen in our lectures that XOR will be 1 if you have odd number of ones. XNOR will be 1 if you have even number of zeros. Okay, this same thing I can also say that this XOR, this is XOR. XOR is odd ones detector. Yes or no? XOR is odd ones detector. XOR is odd ones detector. And XNOR is what? Tell me. XNOR is what? Tell me. XNOR is even zeros detector. Is this clear? Okay, very simple point. Okay, so remember, XOR will be 1 if you have odd number of ones. Odd number of variables are 1, then XOR will be 1. XNOR will be 1 if you have even number of zeros. Okay, if even number of variables are 0, then XNOR will be 1. Okay, so this is the point. Now, if you have odd number of variables, then what will happen? For odd number of variables, for odd number of input variables, if you have odd number of input variables, tell me, if you have odd number of input variables, then in this situation, if you do XOR, you have odd number of input variables. Remember, you have a odd. Okay, then in this situation, XOR will be same as what? XOR will be same as XNOR. In this situation, XOR will be same as XNOR. Yes or no? And if you have even number of variables, if you have even number of variables, for even number of input variables, what will happen? For even number of input variables, what will happen? Tell me. For even number of input variables, what will happen? There, they will be complement of each other. If you do XOR, okay, a even, that will be complement of XNOR. That will be complement of XNOR. That will be complement of XNOR. Okay, so very simple. See, all these points we have seen with proof in our lectures. Yes or no? Please tell me. All these points, every point with proof, I told you. Okay, all these points with proof we have already seen in our lectures. Again, I am telling you. If anyone has any confusion, with proof, we have seen all these concepts in our lectures. Okay, I will put the link in the description. Okay, this video I will upload on the GoClasses YouTube channel, and I will put the link in the description. So if you have any doubt, okay, and if you want to study all these concepts with proof, okay, why these things are happening, with proof, if you want to study, okay, for example, if you want to see the proof of this, if you want to study the proof of this, if you want to study all these concepts with proof, then you can watch the video link I will put in the description. Okay, so you can find the video link in the description. Okay, very simple. So I hope all these points are clear. Now let's come to very important point. But before that, tell me the answer for this question. Tell me the answer for this question. Let me know. Let me know the answer for this question. A, B, C, these are 3 Boolean variables. Okay, you have 3 Boolean variables. This is your exclusive or XOR. and this is your exclusive NOR, XNOR. Some statements are given to you. Which of these statements are correct? Tell me. The first is associative property of XOR. This is correct. XOR is associative. Yes or no? XOR is associative. We know this. We know this. XOR is associative. Is associative. Okay. Very simple. This is associative. So this is true. XNOR is also associative. XNOR is also associative. This is also correct. For three variables, if you have three variables, three means odd. Three means odd. If you have three variables, then XOR, XNOR, they are same. XOR, XNOR, they are same. They are not complement of each other, right? If you have three variables. So your answer will be 1, 2, and 3. Yes or no? Answer will be 1, 2, and 3. Remember, if you have three variables, then they are same. If you have three variables, A XOR B XOR C, that will be same as A XNOR B XNOR C. If you have three variables. What about four variables? Or what about two variables? For two variables, they will be complement of each other, right? Yes or no? For two variables, they will be complement of each other. For two variables. But for three variables, they will be same. For odd number of variables, they will be same. Okay. Now, let's come back to this point. Let's come back to this question. Are these two things same? Are these two things same? Let me tell you, the answer is no. Okay. Let me tell you, the answer is no. They are not same. Okay. See this XNOR gate. Let me tell you, this XNOR gate, this is defined as not of XOR gate. See this. This XNOR gate, remember, this XNOR gate is always defined. Okay, this XNOR gate is always defined as not of XOR gate. See, very simple point I'm telling you. I'm saying that this XNOR gate that you have, okay, this XNOR gate that you have, this XNOR gate, let me tell you, whatever number of inputs you take, it does not matter. Okay, you can take any number of inputs. Okay, whatever number of inputs you take, for example, maybe A1, A2, and so on, AN. Okay, remember this point, that this gate, this is your XNOR gate, right? Correct? What is this? This is your XNOR gate. This is your XNOR gate. See, this is defined as XOR and then bubble. This bubble means complement. See, this bubble means complement, right? Correct? This bubble means complement. So whatever number of input variables you have, whatever number of inputs you take, remember, this is actually defined as XOR complement. Is this clear? So first you do XOR, and then you do complement. Please tell me, did you understand? Let me know. See, this XNOR gate, this is defined as complement of XOR gate. Okay, this bubble means complement. Okay, so you have XOR gate. See what is happening here. Notice, so far here you have XOR gate. This is your XOR gate. And then you do the complement. Okay. Now notice something very interesting will happen now. Okay, whatever number of inputs you take, okay, this is what I'm saying. This is always defined. XNOR gate is always defined as not of XOR gate. Okay, is this clear? See, very simple point. Okay, let's see this. If you have three inputs, see, you already know. Okay, focus, gate versus function. See, you already know that if you have three variables, then these two things are same. This thing is same as this thing, right? Agree? Yes or no? This we have already seen. This is correct. Okay, but see, this gate, when you have this XNOR gate with three input, this XNOR gate, when you have this XNOR gate with three inputs, ABC, remember this point. This is defined as complement of XOR. This is what I'm saying. Okay, this is what I'm saying. See, here you have XOR. So far here what you have XOR. Okay, here you have XOR, correct? XOR means A XOR B XOR C. Okay, and then you have this complement. Then you have this complement. So finally your equation will be what? Your equation will be what? That will be XOR and then complement. XOR and then complement. Is this clear? This is what I'm saying, that this Y, this is always defined as complement of XOR. Complement of XOR. Is this clear? Let me know. So something very interesting is coming now. See, something very interesting is coming now. So when you have this XNOR gate, when you have this XNOR gate, when you have this XNOR gate A, B, C, okay, then this is same as what? Tell me, this Y will be equal to what? This Y will be equal to, first you take XOR, then you take complement, right? Agree? Agree? Yes or no? Because this is complement. Because this is complement. Is this clear? So this Y will be equal to XOR and then you take complement. Correct? Now. But we know, what we know? What we know? We know that if you have odd number of variables, then that is same as XNOR. Okay, yes or no? If you have odd number of variables. So actually, what it will become? Okay, it will actually become A complement, B complement, C complement. Yes or no? So this is just something interesting. Okay, this is just something interesting, that remember this point, that when you have gate, this digital circuit, so please notice here, that this is not equal to, this is not equal to A XNOR B XNOR C. Is this clear? Please tell me. This is not equal to A XNOR B XNOR C. Okay, this gate, this is your XNOR gate. This is your XNOR gate, and this is defined as, this gate is, what is this gate? Tell me. This gate is not of XOR gate. This is not of XOR gate. Is this clear? This is interesting and this is important. This is not of XOR gate, and this is your not. Here you have this bubble means not. This bubble means not. So remember, your XNOR gate, that is not of XOR gate. That is not of XOR gate. Okay, so this is what I'm saying. So please understand that. Okay, please understand gate versus function. Okay, gate versus function. Gate versus function. So please understand these two. Gate versus function. Okay, in this gate, okay, remember, in this function, you know that if you have three input variables, then they are same. Okay, and if you have two input variables, then they are complement of each other. Yes or no? Agree? Correct? And if you have, see, if you have three input variables, they will be same. If you have two input variables, they will be complement of each other. This you know. But in this gate, remember, in this gate, whatever you do, okay, whatever number of input variables you take, it does not matter. If you have A, if you have B, okay, then here, if you have two, then tell me what you will get. Remember, your output is always A XOR B complement. Okay, but here you can notice, if you have two inputs, that will be same as XNOR, right? Agree with me? Yes or no? If you have two inputs, that will be same as XNOR. If you have two inputs, your output is XOR complement. Your output is XOR complement. First you take XOR, then you take complement. That will be same as A XNOR B. But this will not happen for three. Yes or no? If you have three, then this will not happen. A, B, C. Okay, remember, your output will be, first you take XOR and then you take complement. Now, this is not same as A XNOR B XNOR C. Okay, is this clear? Please tell me. Understood? Is this clear? So this is the simple point, that whatever number of input variables you take, okay, this XNOR gate, for any number of input variables, does not matter. For any number of input variables, this is always what? For any number of input variables, this XOR gate, for any number of input variables, is always defined as not of XOR gate. Okay, not of XOR gate. This is always defined as not of XOR gate. Is this clear? Please tell me. Is this clear? Okay. So this is the point. Okay. So you can see here, if you have two input variables, if your input variables are two, then you can easily notice, see here, this is from Morris Mano. This is from Morris Mano. Okay. First you do XOR, then you do complement. Yes or no? First you do XOR, and then you do complement. This bubble stands for complement. This bubble, remember, this bubble stands for complement. Is this clear? This bubble stands for complement. This bubble stands for complement. So first you take XOR. This is your here. So far here you got XOR. And then you take complement. This will become XOR and then you take complement. Okay. But for two input variables, this will be same as XNOR. Agree with me? For two input variables, this will be same as XNOR. For two input variables, this will be same as XNOR. For two input variables, this will be same as XNOR. Okay, so very simple. Okay, so remember, for three input variables also, whether you have three input variable, two input variable, odd number of input variable, even number of input variable, XNOR gate is always defined as not of XOR gate. Okay, so finally tell me, this XNOR gate, this will be equal to what? Tell me. This will be equal to, first you take XOR, then you take complement. First you take XOR, then you take complement. Okay, remember, this is not same as like this. You cannot write it like this. Okay, but you can write it, first you take XOR, then you take complement. Okay, so remember, this will be same as first you take XOR, then you take complement. Now you tell me one thing. This thing, okay, this is same as what? This thing is same as what? Tell me. This thing is same as what? Tell me, this thing is same as what? This is same as XNOR. Okay, this is same as XNOR, and then you take complement. Okay, so this is the point. I hope you understood. Okay, so just remember that XNOR is not of XOR. Okay, you can see this is given in the Morris Mano also. This point is given in the Morris Mano. You can read this. Read this. The XNOR gate is the complement of XOR gate as indicated by the bubble. Is this clear? The XNOR gate is complement of XOR gate as indicated by the bubble. You can also see this from the electronics.stack exchange. On this website also, this is given. Here you can see. Okay, so very simple point. So remember, XNOR gate, that is complement of XOR gate. Okay, so you can see here. Okay, now let's move on. See, here also you can notice XNOR gate is logically equivalent to, I am talking about gate here. Okay, XNOR gate is logically equivalent to inverted XOR gate. XOR gate followed by NOT gate. I hope all these points are clear. So this is the conclusion. You can see this conclusion. Very simple point. So this is important, that XNOR gate is always defined as complement of XOR gate. Okay. So I hope you understood all these things. Is this clear? Please tell me. Let me know, is this point clear? Please tell me. All the points, are they clear? Now let's see this GATE exam question. This is GATE Electronics 2010 question. Let's solve it. What this question is asking? See, the question is saying, for the output to be 1, the logical circuit shown, this is the logic circuit that is given to you. Now the question is asking, this output will be 1. When this output will be 1, the input combination should be. What the input combination should be? Okay, so let's see here what the input combination should be. Now you can easily notice one thing. Tell me one thing. See, can you notice these two inputs, they are complement of each other? Yes or no? See, very simple way to solve this question. Let's solve this question. A very simple way I am telling you. Can you notice, if I call it X, can I call it X complement? Tell me. See, if I call it, let's call it X. Can I call it X complement? Yes or no? They are complement of each other. Agree with me? Please tell me. Okay, what is this X? Whatever. See, this X is basically XOR. This X is basically XOR, but you can see this will be X complement X bar. Okay. Now, what is this F? Can anyone tell me what will be F? What will be the equation for F? What will be F? Let me know. See this F, this is your 3-input XNOR gate. This is your XNOR 3 gate. This is your XNOR 3 gate, 3-input XNOR gate. This is your XNOR 3 gate. So you tell me a simple point I'm asking. If you have XNOR 3 gate, if you have this XNOR 3 gate, 3 input variables are there. Okay, 3 input variables. One is X, another is X bar, another is C. So tell me what F will be equal to. Which is the correct equation? Can I say F will be equal to XNOR? Is this correct? Is this correct? Or is this correct? Which of them is correct? Tell me. Which of them is correct? Remember, this is not correct. This is correct. Okay. Is this clear? See, very simple point. Okay. This is a point. This is an important point. You can see that if you have XNOR gate, this XNOR gate is always defined as complement of XOR gate. Okay. So if you have this XNOR gate, A, B, C, remember this Y, okay, this Y, this is not equal to A XNOR B XNOR C. Okay, this Y is actually equal to, first you do XOR and then you do complement. Okay, very simple point. This we have already seen. So now you can see finally here what F will be equal to. You can easily see F will be equal to what? F will be equal to X XOR X complement XOR C whole complement. Okay. Now you tell me a simple point. What this X XOR X bar, what that will become? X XOR X bar, what that will become? Please tell me what that will become. X XOR X bar. X XOR X bar. That will become always 1. Yes or no? That will be 1. Very simple. Because XOR, you already know this point. We already know that A XOR B is equal to 1 if and only if they are different. If and only if they are different. Okay, yes or no? A XOR B is equal to 1 if and only if A is not equal to B. So if I do this, X XOR X bar, that will be always equal to 1. So what I can say, it will be 1 XOR C complement. Now tell me what is 1 XOR C? Tell me what is 1 XOR C? Let me know. What should I write here? What should I write here? See, very simple. If C is 0, what will be final result? If C is 0, what will be final result? See, this 1 is fixed. If C is 0, then the final result will be 1. If C is 1, then the final result will be 0. Yes or no? So can you notice? Whatever C is, we are writing the complement of that. So remember, this will be C bar. Okay, this will be C bar. So finally, what I can say? I can say this will be C bar whole bar. That will be same as C. So remember, your F is equal to C. Yes or no? Your F, that is equal to C. That's it. So F will be 1 when C will be 1. Agree, yes or no? F will be 1 when C will be 1. That's it. So very simple. F is 1. F is equal to C. That's it. This is the point. F is equal to C. F is equal to C. What that means? That means F1 if and only if C1. F will be 1 if and only if C will be 1. Okay. Is this clear? Let me know. F will be 1 if and only if C will be 1. So what will be the answer? These are the options. F will be 1 if and only if C will be 1. So the answer will be option D. Is this clear? Okay, very simple. F will be C. That's it. This is the point. F will be C. I hope this point is clear to everyone. Is this clear? Let me know. So the answer will be option D. This will be the answer. Now in this question, let me tell you what are the misconceptions. What are the misconceptions in this question? See, in this question, the misconception will happen when? When the misconception will happen? Please tell me, what is the misconception? See, very simple. You can notice they are complement. If this is X, can I say this will be X bar? Please tell me. If this is X, if this line is X, here, if this is X, then this will be X bar. Okay. And this is your C. See, the misconception will happen if you write this F is equal to XNOR of these three. Okay. If you write like this, X, XNOR X bar, XNOR C. If you write like this, this will be wrong. Remember, if you write like this will be wrong. This will be wrong. Why this is wrong? Tell me why this is wrong. If you write like this will be wrong. Why this is wrong? Because I told you this XNOR, this XNOR gate, this XNOR gate, this is defined as complement of XOR gate. Okay, remember this point. Always this XNOR gate, remember this Y is not equal to, this Y is not equal to A XNOR B XNOR C. This Y is actually equal to A XOR B XOR C complement. Okay, this is actually equal to A XOR B XOR C complement. I hope this point is clear. Okay, so remember this point. Always, this XNOR gate is not of XOR gate, is not of XOR gate. Okay, so first you find XOR and then you do the not. Is not of XOR gate. Is this clear? Okay, very simple point. So remember this point. We know that if you have 3 input variables, okay, please understand the difference. If you have 3 input variables, then these two will be same. A XOR B XOR C, this is same as A XNOR B XNOR C. Yes or no? This will be same. This we know. Okay, but this will, okay, remember this is correct. This is always correct. This is always correct. But the point is, this XNOR, this is always defined as complement of XOR. This is the point. This XNOR gate, this is your XNOR gate. This is your XNOR gate. Remember this XNOR gate, this is defined as complement of XOR. First you do XOR, then you do complement. This is how it is defined. Okay, so very simple point. So remember, in this question, the mistake, some students will make this mistake. If you do this, your answer will be wrong. Tell me, if you do this, then what your F will be? See, if you do this, first of all, you tell me what this will be. Tell me, what is X XNOR X bar? What that will be? That will be 0. That will be 0, right? Yes or no? X XNOR X bar, that will be 0. We already know this, that A XNOR B is equal to 1 if and only if both are same. Okay, we already know this. A XNOR B is equal to 1 if and only if both are same. Okay, so here what will happen? If you look at this, what you will get? Please tell me. If you look at this, what you will get? You will get 0. 0 XNOR C. What is 0 XNOR C? Please tell me what is 0 XNOR C. What should I write here? What should I write here? Very simple. See, if C is 0, I will write 1. If C is 1, I will write 0. Yes or no? So finally, I am writing C complement. You can notice whatever C is, I am writing its complement. So remember, this will be equal to C complement. So what you got? You got F equal to F complement, F equal to C complement. If you do like this, which is wrong. But if you do like this, then F will be equal to C complement. Now tell me which options will be correct. Which options will be correct? Tell me now which options will be correct. F equal to C complement. Now F will be 1 if C is 0. Okay. Now tell me which option will be correct. If you do this, then option ABC will be correct. Now option ABC will be correct. Is this clear? Please tell me. Now option ABC will be correct because F will be 1 if and only if C will be 0. Okay, F will be 1 if and only if C will be 0. And that means option ABC. So is this clear to everyone? That if you do like this, this will be wrong. This will be wrong. Okay, so please understand. In this question, please understand that if you do like this, that will be wrong. Okay, I hope all these points are clear. So remember, this F is not equal to, please understand, this F is not equal to X XNOR X bar XNOR C. What this F is equal to? Please tell me. What this F is equal to? This F is equal to, first you take XOR, then you take complement. First you take XOR, then you take complement. This is correct. Okay, so if you solve it, you will get answer is option D. This is your GATE Electronics 2010 question. Let me tell you, this question will become very interesting if this is MSQ. If this is MSQ, many students will do like this and they will get wrong answer. Just think about it. If this question is MSQ, If this question is MSQ, then many students will do like this and they will get wrong answer. But the correct answer is actually option D. Okay, just think about it. Is this clear? This important point I wanted to discuss with you. Is this clear? Please tell me. Let me know. Let me know. Is this point clear to everyone? Anyone has any doubt? Anyone has any doubt? Let me know. Just remember this point. Okay, just remember this point. If you have this XNOR gate, and your inputs are total, let's assume total n inputs you have. This n can be even or odd. A1, A2, An. Then what you will write? This y, what you will write? Please tell me. This y, how will you write this y? Remember, this n can be even or odd. This n can be even or odd. This n can be even or this n can be odd. Okay, remember. So what you will write this y? Remember, this y you will write as first to do XOR, and then you complement. Okay. Don't write like this. Do not write like this. Do not write like this. Is this clear? Do not write like this. Is this clear? Please tell me. Okay. So simple point. But tell me, if n is even, in this situation, of course, see, this is correct. See, you can always write like this. This will never be wrong. This is always correct. But if n is even, you know that if n is even, then the complement of XOR will be XNOR. Yes or no? If n is even, then the complement of XOR will be XNOR. Okay, if you do this XNOR complement, XOR complement, that will be XNOR. So if n is even, then you can write it like this. Yes or no? Agree? Now both are correct. This is also correct. Is this clear? Please tell me. If n is even. Okay, is this clear? Please tell me. Let me know. Is this point clear? If n is even. Okay, what about if n is odd? Let me know. If n is odd. See, if n is odd, then XOR, XNOR, they are same. Yes or no? If n is odd, then XOR, XNOR, they will be same. They will be same. Correct? Yes or no? These two, they will be same. If n is odd, then they will be same. Okay, in this situation, remember, this is not correct. If n is odd, then in this situation, remember, this is not correct. Okay, so what you have to write? You have to write XOR complement. Okay, so remember, in this situation, this is not correct. Is this clear? Please tell me. Understood? Now is this point clear? Okay, so this is the safe side. See, n is odd or n is even, you can always do this. Okay, just do the complement of XOR. So that's it. Now let's move on. Now let's see this question. This is GATE Electronics 2015 question, a very nice question, a beautiful question. Let's solve it. Let's solve this question. The question is saying a 3-input majority gate is defined by this function. Okay, a majority gate is defined by this function MABC, that is equal to AB or BC or CA. Which of the following gate is represented by this function? A new function is given to you, and the question is asking which of the following gate is represented by this function. Before we solve this question, I want to ask you something very interesting, and that is, are these same? Option B, option D, are they same? Look at option B, look at option D, are they same? 3-input XOR gate, 3-input XNOR gate, are they same? Please tell me. Look at option B, look at option D, and tell me, are they same? 3-input XOR gate, 3-input XNOR gate. They are not same. They are complement of each other. They are not same, they are complement of each other. See, this I told you many times. I told you this. I told you many times that Your XNOR gate is always complement of XOR gate. Please understand, XNOR gate is always complement of XOR gate. Complement of XOR gate. Okay, is this clear? See, XNOR gate is always complement of XOR gate. That is always complement of XOR gate. Okay, so if you have XNOR gate, remember this. If you have XNOR gate, 3 input XNOR gate or whatever input XNOR gate you take, if you have this XNOR gate, remember, this is always complement of XOR gate. Is this clear? Okay, so remember this point. XNOR gate is always complement of XOR gate. Okay, is this clear? So remember this point. So they are complement of each other. 3 input XOR gate, 3 input XNOR gate. See, the difference is this. If you notice this equation is equal to this equation. Yes, they are same. These two equations are same. But these two things, 3 input XNOR gate and 3 input XOR gate, they are not same. 3 input XNOR gate and 3 input XOR gate they are not same. Is this clear? They are not same. They are complement of each other. You can see, if you have 3 input XNOR gate, that will be complement of XOR. Okay, but yes, this equation is correct. But remember, this XNOR gate is defined as complement of XOR gate. So if you have this XNOR gate, ABC, okay, this XNOR, if you have this XNOR gate, you have, let me just write it clearly. If you have this XNOR gate, remember, this is not equal to XNOR, this equation. This Y is actually equal to the complement of XOR. Okay, so this is the point. So anyway, remember, these are different. Is this clear? These two things, they are complement of each other. Okay, these are complement of each other. Okay, anyway, now let's solve this question. Let's come back to this question. The question is very simple. The question is saying a majority function is given to you, M ABC, that is AB or BC or CA. Okay, so what is M ABC? M ABC, that is AB or BC or CA. Now the question is asking, what is this function? A new function that is given to you. What is this function? A new function is given to you. What is this function? The function that a new function is given to you, that is M. Okay, and in bracket what is written? M ABC complement. M ABC complement. What else is written? M ABC C, and this is also given M ABC complement. And what else is given? C is given. Okay, this is what the question is asking. The question is asking, this is equal to what? Are you getting my point? Did you understand this function? Please tell me. See, this M ABC that is given to you, that is AB or BC or CA. This is very simple. Okay, this is very simple. This is given to you. Now the question is asking what this is equal to. Okay, so if you want to solve this type of question, then what is the best way? To solve this type of question? See, what you can do, you can assume this as some X. Okay, let's assume this. Okay, I don't know what is this. Let's call it X. Okay, is this clear? I don't know what is this. Let's call it Y. So finally, the question is asking MXYC. MXYC. Tell me, what is MXYC? MABC is already given to you. What is MXYC? Please tell me. What is MXYC? That will be XY or XC or YC. Yes or no? Very simple. Because MABC is given to you. That is AB or BC or CA. So what is MXYC? That will be XY or XC or YC. Now what we have to find out? Please tell me. What we have to find out? We have to find out what is X. Yes or no? Okay, so let's find out what is X. M is already given to you. M ABC, that is AB or BC or CA. This is already given to you. We need to find out what is x. What is x? What is x? X is complement of m. X is complement of m. Remember, x is complement of m. Okay, so if you find the complement of m, you can apply the De Morgan law. Apply the De Morgan law. Okay, apply the De Morgan law. BC or CA complement. Apply the De Morgan law. What you will get? Please tell me. You will get A bar or B bar and B bar or C bar and C bar or A bar, right? Yes or no? This is what you will get. Correct. Now you can simplify this. You can just multiply. Okay, you can multiply and you can simplify. So what you will get? You will get A bar, B bar. Okay. See, just do this. Just do this. Just do this. Okay. So what you will get? You will get A bar, B bar. What else you will get? Please tell me. A bar, B bar, or I am simplifying this. So A bar, B bar, or A bar, C bar, or B bar, C bar. Correct? Yes or no? Multiplied with C bar, A bar. C bar or A bar. Now you tell me. Now you tell me. Here what you can do, you can apply the absorption property. Correct? Here you can apply the absorption property, right? Yes or no? We already know this absorption property. See, we already know alpha or alpha beta, that is same as alpha. That is same as alpha. This is called absorption property. So you can apply this absorption property. So here you will get B bar. Okay, this will become B bar. So finally what you will get? And remember, you can also include this. Basically these, see, from these three you will get B bar, right? Correct? From these three you will get B bar or A bar, C bar. This is what you are going to get. Is this clear? Please tell me. See, we are just applying the absorption property. We have B bar or B bar, C bar or A bar, B bar. This is what we have. So what you can do, here you can apply the absorption property, alpha or alpha beta, that is alpha. So here you will get B bar, here you will get B bar or A bar, B bar. Again, what you can do? Again, you can apply the absorption property. So here if you apply the absorption property, again you will get B bar. So finally you are getting B bar. Okay, now again you further simplify, what you will get? If you further simplify, B bar or A bar, C bar, multiply with A bar or C bar. So let's continue this on the next page. On the next page, let's continue this. So you have this equation, your x is equal to, okay, let's continue this. So we got x is equal to B bar or A bar, C bar, multiply with C bar or A bar. Okay, now you just multiply again. If you multiply again, then what you will get? You will get B bar, C bar, B bar, A bar, A bar, C bar, A bar, C bar, right? Yes or no? Okay, this is what you are going to get. Correct? Okay, you can see A bar, C bar. Okay, so if you multiply, you will get B bar, C bar, you will get B bar, A bar, you will get A bar, C bar, C bar, A bar, C bar, C bar, A bar, C bar, A bar. Okay, this is what you are going to get. These are same. Okay, you can simply write it A bar, C bar. These are same. You can simply write it A bar, C bar. So finally what you got? You got B bar, C bar or B bar, A bar, or I can do like this. Okay, what I can say? I can say you got A bar, B bar or A bar, C bar or B bar, C bar. This is your x. So finally we got x. Is this clear? Finally we got x. So we found x. X is A bar, B bar or A bar, C bar or B bar, C bar. This is x. So remember we got x. Now we need to find y. Yes or no? We need to find y also. What is y? Y is M, A, B, C bar. This is y. Y is M, A, B, C bar. This is y. So let's find it. Tell me. M is given to you. M is A, B or B, C or C, A. So tell me what y will be. What y will be? Y will be M, A, B, C bar. So it will be A, B or B, C bar or A, C bar. Yes or no? This is what you will get. So you got y. You got x. What is x? X is complement of m. X is complement of m. And what is that? That is A bar, B bar or A bar, C bar, A bar, B bar or A bar, C bar or B bar, C bar. So you got y, you got x. Okay, now what is our equation? What we want? We want m, x, comma, y, comma, c. This is what actually we want. So this will be xy or xc or yc. So remember, we need to find xy. Okay, still we need to find xy. So please understand that we still need to find xy. What is xy? What is xc? What is yc? These are the things we need to find. So, okay, let's find out one by one. What is xy? Please tell me. What is xy? X is, you know what is x. X is a bar, b bar, or a bar, c bar, or b bar, c bar. This is your x. What is y? What is y? Y is ab or bc bar or ac bar. This is y. So if you multiply these two, what you will get? Please tell me. If you multiply these two, what you are going to get? Let me know. Okay, so if you multiply, this will become 0. Okay, this will become 0. If you multiply, this is going to become 0. So it will become like this, 0 or. Now, if you multiply a bar, b bar with bc bar, that also will become 0. Okay, if you multiply this a bar with this, then again that also will become 0. So if you multiply this with any of them, that will become 0 or 0 or 0. Is this clear? Now let's focus on this a bar, c bar. If you multiply this with this, that will become 0. That will become 0. Or if you multiply this with this, yes. Now what you will get? Now you will get a bar, c bar, b. This is what you are going to get. And finally, again, you will get 0. Again, you will get 0, right? Yes or no? Is this clear? Please tell me. Now, finally, if you multiply this with this, you will get 0. If you multiply this with this, you will get 0. If you multiply this with this, what you are going to get? You are going to get a, b bar, c bar. Is this clear? Please tell me. So finally, what you got? Xy is equal to what? Tell me, what is xy? Xy is a bar, c bar, b. Okay, xy is a bar, c bar, b. A bar, c bar, b, or a, b bar, c bar. Yes or no? This is your xy. So remember, we got xy. This is the xy we got. But we also need xc, yc. Okay, xy we found. Now we need to find xc. What is xc? Okay, so let's see xc. X multiplied with c. So if you do that, if you multiply this, what you will get? You will get a bar, b bar, c. Okay, plus 0, plus 0. So finally, that will be a bar, b bar, c. Okay, let's find out what is yc. Let's find out what is yc. Okay, your y is ab or ac bar or bc bar multiply with c. This is your y. Okay, so if you multiply this y with c, then what you are going to get? You are going to get abc. You are going to get abc. So we found everything. Okay, remember, we found everything. We found what is xy. What is yc? We found yc is abc. Yc is abc. What is xc? We found. What is xc? Xc is a bar, b bar, c. A bar, b bar, c. And what is xy? And what is xy? Xy also we have found. Xy is, see, what is xy? Xy is a bar, c bar, b, or a, b bar, c bar. Okay, what is this xy? Xy is a bar, b bar, c, or a, sorry, a bar, c bar, b. Sorry, a bar, c bar, b. A bar, c bar, b, or a, b bar, c bar. A, b bar, c bar. Okay, so finally tell me, this is what you want. Remember, your question is asking mxyc, and that is what you got. Finally, what you got? You got a, b, c bar. This is what you got. Notice what you got. You got a, b bar, c, or a, b, c, or a bar, b, c bar, or a, b bar, c bar. This is what you got. Okay, the question is asking this. Remember, so we got this. What this equation? This equation is, remember, this equation is, that is mxyc. That is equal to, I can say ab, abc, or a bar, b bar, c, or a bar, b, c bar, or a, b bar, c bar. What is this equal to? Please tell me. Now the question is asking this. Remember, we got this equation. Please understand. We got this equation, that is your ABC. Okay, we got this equation. This equation is ABC, or a bar, b bar, c, a bar, b bar, c, or a bar, b, c bar, a bar, b, c bar, or a, b bar, c bar, a, b bar, c bar. So tell me now, This is equal to which of them? This is equal to which of them? This equation that you got. Okay, let's see option A, 3 input NAND gate. Is this same as 3 input NAND gate? Is this same as 3 input NAND gate? Okay, let's see option A. Option A is saying 3 input NAND gate. 3 input NAND gate. A, B, C. Is this same as 3 input NAND gate? In this 3 input NAND gate, you get this, and that is same as A bar, B bar, C, A bar or B bar or C bar. Are they same? Please tell me. A bar or B bar or C bar. Are they same? Are these two same? So option A is not correct, right? Yes or no? This equation you can notice, this is not same as this equation. These two are different. These two are different. Tell me why they are different. Can you give me one situation where they are different? Can you give me one situation where they are different? Please tell me. Give me one situation where they are different. Let me know. Give me one input combination where they will be different. See, these are different. For which input combination? Consider which input combination. Consider A, B, C is equal to. For which input combination they will be different? Please tell me. For 0, 0, 0. Okay, if I take 0, 0, 0, if I take all of them 0, yes, very good. For this input combination, they will be different. You can see. Consider this input combination 0, 0, 0. You can see they will be different. So option A is not correct. Okay, yes or no? Option A is not correct. So I can say option A is not correct. What about option C? 3 input NOR gate. Let's see option C. Let me focus on option C now. Okay, so let's see option C. Option C is thing 3 input NOR gate. A, B, C. This is your 3 input NOR gate. So that will be A bar, B bar, C bar. Are they same? This answer that you have, okay, are they same? This and this, are they same? They are not equal to. For which input combination? Give me one input combination which will distinguish them. Consider which input combination, for which input combination they will be different. For which input combination they will be different. Again, you can take 0, 0, 0. Again, you can take 0, 0, 0, right? Yes or no? If you take 0, 0, 0, this will be 1. Option C will be 1. Okay, but if you take 0, 0, 0, this will be 0. Correct? Agree? Please tell me. You can also consider 1, 1, 1. You can also consider 1, 1, 1. If you consider 1, 1, 1, then this will be 1, but this will be 0. So you can consider these input combinations. You can see option C is also not correct. So remember, option C is also wrong. Now, what about option B, option D? See, this equation that you have, if you notice, this is actually your XOR. If you notice, this is actually your XOR. Why? You can simply see this is your XOR. Tell me why. Remember, XOR is 1 if and only if odd number of ones are there. Yes or no? See, if you see this XOR, A XOR B, you know that this is 1. When this will be 1, if and only if? Tell me when this will be 1. This XOR will be 1 if and only if odd number of ones are there. Yes or no? Odd number of ones are there. Odd number of variables are 1. Odd number of variables are 1. Okay. Is this clear? Yes or no? So if odd number of variables are 1, then when that will happen? Odd number of variables are 1. Okay, remember, this XOR, this will be 1 if and only if odd number of variables are 1. Odd number of variables are 1 means either all of them are 1. If all of them are 1, can I say odd number of variables are 1? Please tell me. If all of them are 1, can I say odd number of variables are 1? Yes. Okay. So you can see either all of them are 1, or what can happen? A is 1, B 0, C 0, or A is 0, B 1, C 0, or A is 0, B 0, C is 1. Is there any other possibility? Please tell me. Is there any other possibility? Let me know. Is there any other possibility? Please tell me. See, very simple point. Very simple point. XOR. This is your XOR. XOR will be 1 if and only if odd number of variables are 1. This XOR will be 1 if and only if odd number of variables are 1. You want odd number of variables to be 1. Odd number of variables to be 1. So all of them can be 1. Or what can happen? A can be 1, BC 0, B can be 1, AC 0, BC can be 0, C can be 1. So this is the point. So finally, this is what I'm saying. This equation that is given to you, that is same as A XOR B XOR C. This is the equation for A XOR B XOR C. Okay. Is this clear? Please tell me. So this equation that is given to you, this is A XOR B XOR C. So remember, I can say this question, in this question, this is given to you, and that is same as A XOR B XOR C. Can I say that is same as A XNOR B XNOR C? Please tell me, please tell me. Are they same? Are they same? Yes. So both are correct. Remember, both answers are correct. Please understand, both answers are correct. So for this question, okay, remember, for this GATE exam question, both these answers are correct. If your answer is this is also correct. And remember, that is same as this. This is also correct. But tell me one thing. See, this is your XOR gate. This is your XOR gate. Yes or no? This is your 3-input XOR gate. This is your 3-input XOR gate, that will be A XOR B XOR C. Is this your 3-input XNOR gate? Please tell me. Is this your 3-input XNOR gate? Please tell me. Is this your 3-input XNOR gate? Is this your 3-input XNOR gate? No, this is not 3-input XNOR gate. Please understand. This is not 3-input XNOR gate because this is not same as this. Okay, so this is the point. This is the interesting point. Okay, this is the interesting point. So remember this point. This 3-input XNOR gate that you have, A, B, C, this 3-input XNOR gate, this Y is not equal to XNOR. This Y is actually equal to, first you take XOR and then you take complement. So your answer will be what? For this question, the answer will be option B. Yes or no? For this question, the answer will be option B. Option B will be the answer. Option D will not be the answer. Answer will be option B. This is your GATE Electronics 2015 question. A very nice question. Okay, yes or no? So this fact is very important. Again, I'm telling you, this fact is very important. See, this is very important point, right? What is very important? What is very important? See, this point is important, that XNOR is always complement of XOR. This XNOR gate, I am talking about XNOR gate. This XNOR gate, see this XNOR gate, okay, this XNOR gate, this is always A, A1, A2, AN. So remember, this is not equivalent to like this. Okay, so please understand, this is actually equal to, first you take XOR, and then you take complement, Okay, so this is the point. This is the point that I want to tell you. Okay, so very simple point. So this is how XOR gate is defined. So remember, this XNOR gate is always complement of XOR gate. Complement of XOR gate. Okay, that's it. So I hope you understood this question. The answer will be option B. Option D will not be the answer. Answer will be option B. Okay, so this is a nice question. Okay, so can you notice this concept is important, right? There are multiple questions in the GATE exam, in the GATE electronics. This concept. Okay, that if you have XNOR gate, this is your XNOR gate. Remember, this is not equal to A XNOR, B XNOR, and so on. This is actually equal to complement of XOR. And this point is important. This point is very important. There are two questions in the GATE electronics. In the GATE electronics, there are two questions. In the GATE computer science also, they can ask these questions. They can ask in the GATE computer science also. So you should take care. Okay. Okay. Thank you, everyone.